Our first contestant is Michelle Gegel. She's a PhD student in mechanical engineering, and she will be presenting to you on feedback control of the laser metal deposition process.
3D printing. It's been called the third industrial revolution. And today I'm going to tell you about 3D printing with metals. So why would you want to be able to 3D print with metals? Well, the real value in 3D printing with metals is the ability to make parts that you couldn't make any other way. And I'll give you an example. Functionally graded parts. What's a functionally graded part? Well, a functionally graded part is where one end of the part is made out of some material, say material A, and the other end is made out of a different material, call it material B. And there's a gradual transition from material A to material B throughout the part. So in application, a dental implant is a part that you would want to be functionally graded. The part that sits inside the jaw, you'd like to be made out of a material that fuses really well to bone. But then the part that attaches to the tooth, you would want to be made out of a strong material so that it can withstand the forces from chewing. So how do we make such a part? Well, there's a 3D printing process with metals called laser metal deposition. And this is the process that my research focuses on. So in laser metal deposition, you have a build plate that you want to make your part on. And there's a laser beam that hits that build plate and melts it. But not all of it, just a small portion of it. And it creates this small pool of liquid metal. And then to this melt pool, you add material by blowing powdered metal into it. So if you want to make a part, you take this melt pool and you trace it on your build plate to make the first layer. Then the machine jogs up and deposits the second layer on top of that. And the process repeats until you have a fully formed part. So what's the problem? Why am I researching this process? Well, it turns out that the process has a tendency to produce parts that don't turn out the way you intended them to. So on the upper right-hand corner of this slide, you'll see some parts that didn't turn out correctly. There's a part that was supposed to be in the shape of a star, and yet we see these gaping holes in the sides. And next to that is a wall build that was supposed to be flat on top, and yet we see these ripples. And if that were a dental implant with bumps on it, you wouldn't be able to use it as printed. So that's where my research comes in. The goal of my research is to incorporate sensors on the machine so that it can detect when small defects are about to form during the process, and it can take corrective action before they come full-blown and ruin your part. So it'll go like this. The machine will print a layer, and then it will scan over the layer it just printed, looking for defects. And based on what it just scanned, it will make adjustments for how it prints the next layer. So let's say that you wanted to make a dental implant that was functionally graded, and you didn't have sensors. You might have to make 4 or 5 defective parts before you would get one good part. So the real advantage to having sensors on this machine is that you would be able to make a part without defects and make it right the first time. Thank you.